Today we will start the new chapter, chapter 2, polynomials. So in this chapter, this is not today's objective. What's the content of this chapter? So we can split the content into three parts. First part is geometric meaning of the zeros of a polynomial. So you know zeros, we will come to that. So there's a meaning in geometric, the zeros of a polynomial. So you know this related with the graphs. So you know if you get a linear equation, you know how to draw the graph. So here in this part, in this topic, we'll discuss how the relation of zeros, the geometric meaning of zero. And the second part, relationship between zeros and coefficients of a polynomial. You know coefficients, you know zeros, and there is some relations. So we'll discuss it in detail. And the third part, division algorithm of a polynomial. Last year in 9th standard, you have started to divide a polynomial by another polynomial. We'll discuss some more in 10th standard chapter. Okay, so there are three topics, main topics in this chapter. Okay, and before we start, we should have a good previous knowledge. That's an introduction. Introduction is the recalling our previous knowledge about the polynomial. That's what I do today. So previous knowledge mainly these chapters. In 8th standard, chapter 2, linear equations, chapter 9, algebraic expressions and identities, and chapter 15, introduction to graphs. And in 9th standard, chapter 2, polynomials, and chapter 3, coordinate geometry, and chapter 4, linear equations in two variables. So you should have good knowledge on these chapters. Okay, then only you can learn this polynomial in the 10th chapters without any problem. Okay, so I request you to read these chapters and make the previous knowledge clear. Okay. So we'll start with the previous knowledge from very beginning. I would like to ask you some questions. So what do you mean by algebraic expression? Algebraic expression, what do you mean by an algebraic expression?
The expressions in which alphabets are included?
Yes, very good. Mathematical expressions where alphabets are included. And you know, then we define polynomial. All algebraic expressions are not polynomial. So what's polynomial? Can you define polynomial?
Polynomial is a one variable.
No. There can be more variables.
Squares will be more than 2.
No. I told at the beginning all algebraic expressions are not polynomials. Okay. So the problem is in algebraic expression, if you write suppose ax square plus bx plus c, is this a polynomial or not? Here a, b, c are constants. Yes.
Yes, sir.
And I ask you another question here. A by x, where x is a variable and a is a constant, plus 1. Is this a polynomial?
No.
And I write here another one. 3x cube minus root 2. Is this a polynomial? No. Any other answer? Yes.
Sir, no fractions.
Now I will come to that. Is this a polynomial or not? Yes, very good. And I will write another one here. Root x plus 4. Is this a polynomial? Yes or no?
No, sir.
No, sir.
Okay, very good. And I will write another one. Okay. Is this a polynomial or not? Yes. Okay.
Yes.
So if you write some positive and negative examples for polynomials, you can get the idea of what's the polynomial, the difference. Okay, here, power of the variable must be a whole number. The variable should have a power in whole numbers. Okay, here x is the variable in the first one, and x square, then x raised to 1. And 2 and 1 are whole numbers. Whole numbers, 0, 1, 2, 3, 4, etc. Okay? And in the second example, the power of x is 3. It's a whole number. Okay? And here 2 is the and 1 is the, both are whole numbers. But you comes to negative examples. Here a by x means a into x raised to minus 1. 1 by x is equal to x raised to minus 1. So here power of x, the variable is minus 1. Minus 1 is not a whole number. So this is not a polynomial. Now what about this? Root x is equal to x raised to 1 by 2. So here 1 by 2 is not a whole number. So this is not a polynomial. So variable algebraic expression with the variables in powers of whole numbers. Okay, and there will be a constant term c, or here 4. A 4 means we can write 4 into x raised to 0. X raised to 0, what's x raised to 0? X raised to 0.
1.
X raised to 1.
1.
1. X raised to 0 is 1. So here the constant term you can also write like this. The constant term into the variable power 0. Okay. So only this kind of algebraic expressions are polynomials. Okay. Now comes to coefficients.
Yes.
Okay. In the third example here, so which is the coefficient of x square? Which is the coefficient of x
3
square?
by 4.
3 by 4. And which is the coefficient of x?
2.
2.
And which is the constant?
4.
4.
Okay. And here in the first example, which is the coefficient of x square or first term?
A.
A.
A. And in the second example, which is
B.
B.
okay, second example, which is the coefficient of x cubed term?
3.
3. Yeah. So you know the coefficients.
Yes.
Yes.
How many terms are there in the first polynomial? How many terms?
3 terms.
3.
3 terms. And how many terms in the second one?
2.
So I write here another one, xyz plus 1. How many terms in this one?
1.
One
2.
only?
2.
2.
2 terms. And I write another one, 4x plus 5 plus 9x. How many terms are here?
2.
3.
3.
Okay.
2.
3.
Okay, we can reduce it, right? For like terms, you have to add, then you want to tell the number of terms. Like terms you can add. So 4x plus 9x is how many x?
13.
13x
13x plus
5.
5. So there's only 2 terms. Okay. So you know terms, you know coefficients. And another thing is, this, if there are only 2 terms, there's a special name for such polynomials,
Quadratic polynomial.
No, not quadratic. In terms of terms, there are 2
Binomial.
binomial, very good, binomial. And if there are 3 terms,
Trinomial.
trinomial. And suppose there is only 1 term,
Linear.
Monomial.
monomial. Okay, so you know how to give such names according to number of terms. Okay, there's a little bit confusion, monomial or linear, and binomial or quadratic, and trinomial or cubic. So for that, what does that mean? So next question is, I write here some degree. Next previous knowledge is degree of a polynomial. You know degree? So I write here one polynomial. So what's the degree of this polynomial? What's the degree of this polynomial?
1.
1. Very good. 1 is the degree. And second one, I write here x square plus 2x
2.
2 is the degree, very good. And C question. Okay, what's the degree of this polynomial?
3.
3 or 4?
3.
Okay, 3 is correct answer. So you know the degree. Degree is the power, highest power of the variable involved in it. Okay, so here x raised to 1, there is no x square term. There is no x square term, so x raised to 1 is the highest power. So 1 is the degree of this polynomial. And the second one, highest degree, there is x raised to 1 is here, x raised to 2 is here. So x square, so is the highest power. So 2 is the degree of this polynomial. And third one, x raised to 0, we can say the constant term is x, 4 into x raised to 0, okay. Then x square is here and x cube is here. So highest is 3. So 3 is the degree of this polynomial. So this is also fine, right? Degree of a polynomial. And we give names as linear and quadratic and cubic according to this degree. Okay, so in this example, the x plus 4 is all we can call a linear polynomial. A linear polynomial. Okay, and x square plus 2x we can call say quadratic polynomial. And third one, for x cube we can call as cubic polynomial. So here we give names according to the degree of the polynomial. And previously, just before we discussed how to give names according to number of terms. Okay, so can you give me one example for another a linear polynomial? Some other example.
Y plus 2.
Y plus 2. Okay, very good. Y plus 2. Okay, it's a linear polynomial. The degree here, the variable involved is y. So variable need not be x, can be any other letter, but usually we take x, y, and z. Good example. Any other in linear equation?
Sir, in one equation only one alphabet is possible, right?
No. More variable can be, but we discuss only single variable equation. So next is how to give names. You know how to give names for a polynomial. Okay. So these polynomials I wrote here. So how can we give names? X plus 4, I want to give name. So you know how to give names for a polynomial, right?
P of x.
Yes, very good. P of x. P of x. We can give names like this. And need not be P. You can also give names like Q of x, R of x, no problem. Okay. But when it comes to here, can I give names like this here? Any wrong? Here?
No,
No, why?
because the alphabet is Y.
Yes. So inside the bracket, you have to mention
Y.
variable name. Here in this polynomial, alphabet used is y, the variable. Okay. So we want to give name p of y or q of y is okay. Okay. So inside the bracket, you should write y. Okay. So now we discussed the degree, then how to give name. And another one is, okay, factors. You know, factors. I can write it 10 is equal to 2 into 5. So I can say 2 is a factor of 10 and 5 is also a factor of 10. Reverse, we can say 10 is a multiple of 2 and 5. Similarly, you can see in polynomial. I write here one x into x plus 1. So what will be the answer? X into x plus 1.
X square plus 2x.
X square plus
1x.
Sorry.
plus x.
X square plus X.
Yes.
X.
So I give names. P of x is a polynomial, that is x, the first one. And q of x is another polynomial, that is x plus 1. And this one in right side I give name. R of x is a polynomial, that is x square plus x. So you can write here P of x into Q of x is equal to R of x. Okay. So here this is like this, right? N is equal to 2 into 5. Here R of x is equal to P of x into Q of x. So how can we say the P of x is a factor of R of x and Q of x is a factor of R of x. And also you can say R of x is a multiple of P of x and Q of x.